Got to give the people, get the people, whoa, 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 what they want. All right, Mr. Bass in these streets. Let's do it. We are talking about sketching graphs of quadratics using key features. Okay, so it's really important. I need you to get all this down in your notebook. I wrote it ahead of time so that you can just pause and write stuff down at whatever pace works for you, but you don't have to watch me write it. So you're going to start this. All right, so first off, I can graph a good sketch of the quadratic function if I have its roots slash x-intercepts, those mean the same thing, and the vertex. So all I need to graph is roots, 2 x-intercepts, which is the same thing, and the vertex. I can always figure out this information from any form, whether it's standard form, vertex form, or factored form of quadratic, by converting forms. But factored form is easiest. So ultimately, I'm always going to want to put it into factored form. But I can get to factored form from any other form. All right? Okay, so now here are your steps. So I'm kind of preloading you with the information, and then we're going to do it together and talk about why. So here are the steps to sketching a quadratic graph, the overview. Okay, so again, you should be writing this down, pausing it as each one goes. All right, so first, convert to factored form if necessary. If you are in standard form, factor it. If you're in, vertex form, move it to standard form, then factor it, okay? But make sure you're in factored form to begin with. Second, find the x-intercepts using the zero product property. In other words, solve for the x-intercepts. Set each of those factors equal to 0 and solve to figure out what the x-intercepts of that equation are. Third, find the x-coordinate of the vertex. So now we're trying to figure out the vertex. So we're just going to find the x-coordinate of the vertex using the roots. And how we're going to do that is because the x-coordinate of the vertex is in between the two roots. It's right in the middle, okay? Once we have found the x-coordinate of the vertex, we're going to then find the y-coordinate of the vertex by plugging the x-coordinate into the original equation. When we've done all of this, at that point, we now know both x-intercepts and the vertex. Or in other words, we know both roots and the vertex. So, what you're going to do in step 5 is graph it. You're going to use those key features to draw your parabola. All right, so hopefully you took time to write all of that down, because if you did, that means you are ready to make this happen and work through some. So now we are going to do this bad boy by example. So, example 1, and the directions are just going to tell us to sketch a graph of the parabola. We're going to sketch a graph of this parabola. And the first example is going to say, let's go with y equals x plus 8 times x minus 6. Okay, so let's think back. Let's think of those steps. At first it says, okay, well, you have to be in factored form. I am in factored form. I'm in good shape. Second one says find the roots. I want you to go ahead and find the x-intercepts for me real quick. Pause it right here and see if you remember how to find the x-intercepts. Hopefully you do. Okay, hopefully you paused and you did, and hopefully you looked at this and you said, oh, okay, well, I have two factors. I got to set them equal to 0. So x plus 8 equals 0 minus 8 minus 8, x equals negative 8. And x minus 6, I got to set that equal to 0 plus 6 plus 6, x equals 6. So these are my x-intercepts, or my roots. One of them is negative 8, 0, and one of them is 6, 0. All right, I'm looking pretty good. So now, let's think about a parabola. Let's just draw this off to the side, all right? here's a parabola. Here is, we'll call this 6. We'll call this -8. If we know this parabola looks something like this, right? Actually, that's wrong. We know this parabola looks something like this. The vertex is about right here, and it is halfway between each of those. Notice, vertex is in between. So we're going to use that information to actually figure out, you know, a vertex. Ooh, let me do this. Remember, the vertex has 2 points. It has an x and a y coordinate. Well, this coordinate right here is the x coordinate. So we're going to need to figure out what is this x coordinate that's halfway between 6 and 8. Excuse me, 6 and -8. So that's what we're about to figure out. So there are 2 ways to do this. So the first way I could do it, the most simple way, is to literally count. All I need is a number line. So let me go here. Boom, boom. Here's 0, -1, -2, -3, -4, -5, -6, -7, -8. 1, 2, 3, 4, 5, 6. There's 6. Okay? I could literally count. I can go 1. I'm going to find what's right in the middle of these. 1, 1. 2, 2. 3, 3. 4, 4. 5, 5. 6, 6. 7, 7. There's my middle point, -1. I could do that every time. So I found out that my x value, because again, this is on the x-axis of this vertex, is -1. Okay? I could do that every time. But I also can find the average. I can also find the average basically between 6 and 8. I can average those out, basically, is what you're doing. Find the median. So I could also do -8 plus 6, which is -2. And if I was finding an average, there are 1, 2 things, so I divide it by 2, and I end up with -1. Same way, a little bit quicker. Okay? So I'm going to say that for the vertex, the x value is -1. So far for my vertex, I found that the x value is halfway between -8 and 6, and the number that's halfway, the x value that's halfway between -8 and 6 is -1. Now, I just need to find the y value of the vertex. Well, how am I going to do that? Well, I know an x value. As soon as I know an x, I can plug it back into the original equation to figure out y. Okay, so we had x plus 8, and I know x is -1, so I'm going to do -1 plus 8. Again, I'm plugging back into this original equation just to make sure you see it. It says x plus 6, and again, I know x is -1, so I'm going to do -1 plus 6 minus 6. And now I'm going to solve this. Okay, what is this? -1 plus 8 is 7. Y equals 7. -1 minus 6 is -7. And -7 times -7 is -49. So now I just figured out my vertex is actually -1 and -49. So let's bring everything that I know. I know my x-intercepts are also negative 8, 0, and I'm just taking this information from the top right here, and 6, 0. So, my last step, I have all of my key features. Go ahead and graph. So let me draw x-axis, y-axis. X is negative 8, we'll say negative 8 looks like here. Y is 6, we'll say 6 looks like here. My vertex is at negative 1, we'll say negative 1 is right here. And my Y of the vertex is at negative 49. Now obviously negative 49 would be way down, but we're just going to show negative 49 is about here. So here's my vertex, and again, that's why this is a sketch of a graph. It's not necessarily super accurate. And we're just showing what it looks like. We're going to go up, boom, boom. There's my sketch of the parabola. And as long as you've labeled each of the pieces, you should be good to go. All right, there's one with a lot of instruction. Now let's do example 2. And example 2 is going to have less instruction. Example 2 says y equals x minus 3 and x minus 9. Okay? Alright, I want you to actually go ahead and try to sketch a graph for that. I want you to try to do the whole thing on your own. Pause it. Try it. You never know what happens. I think you guys got it. Boom. Alright, you paused it. So now I'm going to walk you through what I would have done. I would have said, okay, this is in factored form. I'm going to look for the x-intercepts first. So I know x minus 3 equals 0, plus 3, x equals 3. So I know one of my x-intercepts is at 3, 0. X minus 9 equals 0, plus 9, x equals 9. So one of my x-intercepts is at 9, 0. Alright, I have my two x-intercepts. So if I had a number line, here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 3, here's 9. Going 1, 1, 2, 2, 3, 3. Shoot. Did I mess up? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ha! I did mess up. You see, that didn't even make sense. My bad, guys. Can't count. Mr. Bass can't count. Trippin'! 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I knew that wasn't right. 1, 1, 2, 2, 3, 3. See how they met right in the middle? Add 3 and that is 4, 5, 6. 6 is my x value of the vertex. So the vertex, so far, we know the x value is 6. And all we need to figure out is what is the y value. We're unsure. But let me show you the other way you could have done that. You could have said 3 plus 9 is 12. And then there are 2 terms here, so you divide it by 2. 12 divided by 2 is 6. 6 is the middle point between 3 and 9, which I just want to give you multiple ways to figure that out. So now, since I know the x value of the vertex is 6, I'm going to go ahead and plug that in. Y equals 6 minus 3. Y equals 6 minus 9. Y equals 3 times negative 3. Y equals negative 9. Boom. I just found out that the y value is negative 9 in my vertex. Okay? So now I'm coming to here. And I get to see that we have x-intercepts at 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have x-intercept at 3, and we have an x-intercept at 9. We have a vertex at negative x is 6, and y is negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at that. Notice I'm labeling that that's negative 9. 4, 5, 6. Here we go. And there we go. There is my parabola. Good to gizzo. All right. Hopefully yours looks something like that. Oh, and it would be good. Make sure you give me this 3. I want to know that this is 9. Okay? All right. I'm going to do one in standard form. So this is going to be example 3. And I need something in standard form, so I'm going to go ahead and get something right here. Let me see. That's not going to do it. Give me one sec, guys. Sorry about that. Here we go. Okay. So we're going to say x squared minus 2x minus 48. X squared minus 2x minus 48. And we need to graph this. Well, you should be looking at this, and the problem is it's not in factored form, which means I need to factor it. So I got to go here and say, okay, well, let me use this box method right here, area model. This is an x squared. This is a negative 48. I know blank times blank. So for these two boxes, I know blank times blank has to be the same as these two. Let me go ahead and get rid of that. There we go. Blank times blank needs to equal negative 48. And blank plus blank needs to equal negative 2. So if I have negative 48 and negative 2, 6 times 8 is 48. I need my 8 to be negative. 6 plus negative 8 is negative 2. This is 6x. This is negative 8x. This is x times x. 6 minus 8. So again, if I factor this, I end up with x minus 8 times x plus 6. Okay? And now we are back to exactly what we did before. For example 3, I want you to go ahead and finish it off. All right, you paused it, you finished it off right there. Hopefully you got to the point where you said, all right, well, ultimately I'm not going to do all the work, but I know my x-intercepts are x equal, tripping. Know my x-intercepts. Hopefully you should have gotten 8, 0 and negative 6, 0. For your vertex, you should have gotten, what's between 8 and negative 6 is negative 2, 2 divided by 2. Should have gotten an x value of 1, and you shouldn't have gotten a y value. Let's see, I could plug it in. I don't know. 1 minus 8, 1 plus 6, y equals that. Negative 7, ooh, another 49. Y equals negative 49. Okay, you should have gotten that for a vertex, which means if you were to draw it, call this 8. We'll call this -6. Call this 1. We'll call this -49. Should have looked something like that. All right, so there you go. We did all the things. Go ahead and log in, get the homework done. It's just one worksheet. It's relatively short. You guys are doing awesome. Keep it up. Thanks.